right. Hope you guys are enjoying the event so far. Just to let you know, there are some drinks and some snacks on the back you can go and enjoy. We don't have a break for this event, so you can either feel free to go to the restroom or have a drink at the back. Next up, we have Chee. You cannot go anywhere, sir. You're up next. So next up, please give a round of applause for Chee from Nethermind.
Oh, it's coming? Oh, hello everyone. I was thinking of grabbing a drink, but I was not allowed to go grab a drink. But okay. It's only 30 minutes. We can all do it. I can do it. No, I'm good. Thank you for the offer, though. Thank you. Appreciate it. Cool. Great to see all of you in a wonderful Saturday afternoon. I'm Chee. I'm a developer and developer evangelist from Nethermind. We have a booth right over there promoting Voyager, which is an explorer that I work on with my colleague here, Wen Kang. Say hello to everyone. So yeah, if you have any questions of Voyager or Nethermind in general, head to our booth. We'll be more than happy to let you know. So again, I'm Chee, and today's topic is going to be cheat sheet to Cairo 1. So we have heard a lot about Cairo 1, and throughout the entire afternoon. So you may be wondering, what on earth is that, right? How do we write Cairo 1? Do I have to learn a new language? I think someone asked me, probably he left, but yeah. So yeah, let me just dive straight in. Oh, okay. So I'm from Nethermind. A few more necessary marketing content. So what Nethermind is that Nethermind is a company that does blockchain research and software engineering for various protocols and so what we do is that we build toolings, we do smart contract auditings, we build toolings like the Voyager Explorer for Starknet, we do cryptography research, so on and so forth. Again, for a full list of what do we do, feel free to approach it at the booth. And what we build on Starknet, however, are these three main things. Horus, it's a formal verification tool on Cairo. So for those who like to secure their contract using math and formal verification technique, Horus is something that you definitely have to check out. Juno, it's a client node built for Starknet. So what is a client node, you may ask? Think of the client nodes of Ethereum, like the Nethermind client, coincidentally, same name. Yes, Nethermind client is built by our company as well. And the more famous Geth client. So Juno is similar to those clients, but they are now on the Starknet ecosystem. And finally, Voyager, which is the team I'm working in. We have T-shirts over there for Voyager. I'm wearing one, so if you like it, go grab some. All right, enough marketing. All right, let's see. Okay, more marketing. So why Cairo? So recently, Cairo 1 has hit a crazy all-time high. The mainnet launch for Cairo 1 officially is only like 2 or 3 weeks ago, and we are seeing this little hockey stick diagram. So exponential increase of people writing code and develop on Cairo 1. And again, I got this from Voyager. Here's the link. This is I've said it many times because this is the team I'm working for. So what I'm trying to do is I'm begging you guys to check Voyager online out. Oh. All right. I hope that's it. Yep. Okay. So we want you to write Cairo 1 code. So how do you want to write Cairo 1 code, right? So a show of hands as to how many of you are developers in this room. Oh, a good number. How many of you are familiar with Solidity already? Oh, a good number too. How many of you likes? Okay, fine. No more questions. So the goal of today's my talk is to show you that writing Cairo 1 code is not as hard as you would think. It's just a syntax change from our Solidity code. So I'm going to take a ERC20 example. So we know that ERC20 is defined by a certain standard, like certain functions and events has to be present in the contract to be called ERC20. Someone just asked me about does Starknet has ERC721? The same concept applies. If you have the same event and the same function, then it will be classified as an ERC721. In this case, ERC20. So these are the functions, the function parameters, and the events that it should be emitted to be considered an ERC20. So, yes, this is an example of how of the contract that we are going to rewrite into Cairo 1. It's a example from OpenZeppelin. So we are going to rewrite one of the most commonly used library from ERC20.Sol to ERC20.Cairo. And first up, how do we start with the contract body? So in Solidity, this is how we typically would write it, contract ERC20, and then you include the whatever code in this little parentheses, right? And how do you do it in Cairo? Cairo 1. You just swap out the contract to a mod, stands for module, and then what you do is that you have this macro on top of the module to declare that it's a contract. And then you put whatever logic you want in the contract into this body. So again, from here you can see that it's very simple, not much has changed. Just a simple task of memorizing the differences. So again, for you Solidity's developers or devs who have raised up their hand just now, no excuses. I expect you to start writing your first line of Cairo code tonight. Yes. And again, okay, so one thing that's very, very important in a smart contract is that we store values on chain, right? So in Solidity, these are the typical values that we may see. We may see a mapping. Mapping will, in this case, it tells like how much this address owns in the contract. The allowance, same concept. And we have strings and we have UN256. So how do we rewrite all this into Cairo 1? We have to declare a struct, and then we put all these things into a struct. And mapping is now is known as legacy map, and address is known as contract address. The only difference is that you need to import the contract address struct from a predefined module. So you have to use Starknet contract address. And then this is the value. UN256 is U256 in Cairo 1. And UN256 total supply over here is now U256. It's very similar except for the string, which is now replaced as felt256. So it's going to be a short string. This is one quirky thing for Cairo right now. Full string support is not there yet. I heard it's coming soon. But the workaround is that you use a short string. That means it only supports like 31 characters. But we do not need so many characters for name and symbol, right? 31 characters should be enough for a use case, 99% of the time. So yeah, so rewriting the storage, it's simply wrapping it into a struct and changing some of the syntax. And then you're able to get full functionalities as you would in Solidity. All right, cool. Any questions? Fantastic. Okay, events. Events are very important because they tell the users of the state update of the transaction. So if your transaction emits an event, for example, emits this transfer event, we know that someone has sent the from address has sent to a to address a certain amount of tokens because this is ERC20. So it's very important for us to have events in a smart contract. And of course, Starknet in Cairo 1.1 also have events, and this is how you do it. You just declare like a empty function because the parentheses are empty. I mean, the curly braces in there are empty. And then you just mark the event with a event macro. So it's pretty similar, right? If you ask me, like, yeah, someone's nodding. Thank you for agreeing. And storage. So constructor. It should be called constructor. So constructors are when you try to initiate your contract when you at the point of deployment. So when I deploy, for example, I give my smart contract a name and a symbol. In this case, how you do it? You just have a function called constructor, mark it with a constructor macro, and everything over here is the same. So writing to a storage uses this write function, but in Solidity, it's just directly replacing this this thing that you know that is going to be a universal storage. Now, in this case, you may argue that you need to write more steps. You need to write. You need to include this write method, function. But I would argue that it makes things very explicit. It makes you very hard to make mistakes because now you know that name is actually a storage as compared to this one. This one could be like, I don't know, some local variable. If this is like a huge, this has huge lines, huge line of code, you could be mistaken as a local variable and you have all sorts of like shadowing problem and stuff like that. But this is very explicit. That means it shows that you're trying to update the storage in some sort. So this is better, if you ask me. It requires more. It requires you to write more, but it's better. So we have covered constructors, events, and how do we view from the state? So in the world of Solidity, to have functions that doesn't change the state, that means you're just trying to read from the blockchain, you will include this view keyword. So again, underscore name, it's a storage that you store on blockchain, and by calling this, and it's a view function, you know that you're just reading from the state. You're not changing the state. So the concept is very similar to in Cairo. What you do is that you have a view macro instead of a view keyword. And in there, it's exactly the same, except that now it's Cairo 1 being more explicit. It's a read function instead of like just directly returning the storage. So again, this makes things very clear. When you see read, you know that it's trying to read from the storage, and you reduce the possibility of making a mistake. Same like how you would write into a storage, right? Cool. So external functions. So now we have a look. We just now have looked into how we will read from the blockchain. So how do you write and change the state of the block of the smart contract in the blockchain? So over here, sometimes that's allowance. You just have to mark your function with a external macro. But without that, you'll be a private internal function, which I'll talk about later. So with this, your function is able to be called from the outside world. For those who have used Etherscan, you have seen like this read and write contract. We have those in Voyager as well. So all these external functions will appear in the write function. So when you want to interact with it, you need to connect your wallet, pay some gas, blah, 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 and then you're able to change the state of the contract. Just like how we do it in Etherscan, this is how you do it in Voyager. And to make it possible, you have to mark your contract with the external macro, right? Cool. And internal functions. So these are like private functions. They are not being called by the outside world. In Solidity, you mark it as internal or private. So these are the two keywords that people generally use. In Cairo, you don't have to write anything. That means it's not being exposed to the outside world. Simple as that. And one commonly used function is message.sender. For those who are not familiar with Solidity message.sender, it means that the sender of the transaction. So that means if I were to interact with the contract, I try to transfer my funds to maybe him, and I initiate this transaction, the message.sender will be my address. So this is a very commonly used function block in smart contract, and it's very important too. So in Solidity, it's just message.sender. In this case, the owner is the sender. How do you do it in Cairo? You have to import a function from a module, from a crate or module, and then you call get caller address instead. So again, we can see that this is merely a syntax change. And in a lot of cases, you would like to revert your transaction, meaning that if the transaction doesn't fulfill a certain requirement, such as if you are trying to transfer more than you have, the entire transaction will revert, and then all the states that should be applied will be rolled back. So this is something that's super, super important in the blockchain world. So imagine that I try to send you money, but it checks that I don't have the money, and then I will stop sending you, and then all the states that have been applied before will get rolled back. So that means the transaction executed and it reverted as if nothing has occurred before prior to that. So that means no state change has occurred. So in Solidity, you either use the revert custom error keyword, or you use require. And in Cairo 1, you assert. So in this case, it's checking for address 0. Address 0 requires like a function. This is impo of the contract address. So from dot is 0 is just like address 0, and you need to import these two very important module that is zeroable and context zeroable. And then this is the error message that it's over here. So yeah, basically you can see that this is how you rewrite your error message, and just apply that to all the error message you have in your contract. Okay, so in the library that I'm using, Open Zeppelin, when you approve a maximum amount of allowance, it's as if you're allowing someone to transfer for you infinitely. So the max function is kind of useful in this case. We don't we don't use max a lot, but in this case, yes. So I might as well show you how to do it. Solidity has a nice keyword called .max. That means that you are getting the max value of UN256. But Cairo doesn't have that yet, so there has to be a workaround for that. And to do that, you are checking for the lower and upper part of the UN256, and then you are checking for the max value of UN128. Because U256 in Cairo is made of 2 128. This is a bit confusing, and I And feel free to always raise up your hands to ask me after the session or in the booth to clarify more on this. So yeah, this is slightly more confusing, I agree. All right, cool. Any questions? All right. Oh, you have a question? Yes, please. This is a function that I create to try to check if the value is of max or not. Because everything in Cairo is in felt, and felt is only 252 bits. It's not enough, so we need 256 bits. So we are missing off like 4 bits. If you have the parity, it's 5 bits. So the workaround, I mean the solution to have 256 bits supported is that they took two 128 bits and they concat together. So U256 in Cairo is actually made up of a struct of a high and a low key, and then them combining together forms a struct that represents U256, and I'm checking that the low and the high are max values. So I'm glad you asked that question because I can now elaborate that in a better way. And this is just saying that it's U128. All good? Cool, thank you. Thanks for the question. Any more? Good, fantastic. And okay, how do we admit events? So we have declared events. Now we would like to admit events to show that we have a change in the state or whatsoever. So this admit function allows you to admit like a transfer event saying that address 0 is sending money to account, which is the receiver address, and you of a certain amount. In Cairo 1, you are just calling a function. You are just calling a function. This is like calling a function. So in this case, I'm sending the 0 address is sending to the account and amount. So this is the equivalent of emitting an event in Cairo 1. And for those who have been writing Cairo 0 prior to that, loops weren't supported in the old Cairo version. So the strategy was used recursion, which is really bad. I know it's horrible. And the Cairo developers have heard every one of you, including me, and then they have now included loops. So you're able to do loops now. So this is how you do it. You loop and then you break it when the condition has met, and then whatever over here, it's the logic that you want. So Cairo 1 supports loops unlike in Cairo 0. I thought I'd point that out in case there are some Cairo 0 devs over here that haven't been writing Cairo code for a while. So loops are now supported in Cairo 1. And with that, it makes life much easier. So this is how it will look like at the end of the day after we have tried to convert manually our code from Solidity to Cairo. Contract header, remember that we have this mod and then we mark it with a macro contract. This is the imports that we have, imports. The storage, we declare all that in a struct. The events goes here, like remember all the events are like, have this macro. Of course, you can rearrange this into whatever form you want. I just decided to clump them together for readability and good practice. Constructor, view function, and external function. These are the logics that I try to talk about, the asserts, the reverts, the checkings of assert again, the writing of balance to the storage, and emitting of the transfer function. And yeah, and get caller address. And this is a private function of this one, and return true. As if this is like a ERC20, contract and solidity. Now it's on Cairo. So once you have written your code, and once you have deployed it, you will want to interact them on Voyager. So I have tried to interact with my contract, and this is the contract transaction detail page. It will show you when you transact, the timestamp, the fee that you use to pay to transact a transaction, and the sender and the deployed contract. So this is a deployed. This is the transaction when I used to deploy the contract which I written just now. This is the link. I don't think you would type that in, but just to make sure you believe me that the link is, I actually deployed, this is the link. But yeah, so these are the things that you will see in Voyager Explorer. And in the contract page, what you see is that we mark it as contract. If you go to the address that you deployed, which is this one, you'll say it's contract, and it's Cairo 1.0.0. That means this contract is Cairo 1. So that means you don't have to upgrade it with Genesis, the old one. There was an old Cairo. We'll warn you if it requires an update. And it'll show you like this is type ERC20, which is something that we try to do, right? We try to write ERC20 contract on Cairo. You try ERC20, the created date, and the class hash. And if you want to interact with your contract from the Voyager, you can do that as well. Over here is the read function. That means all the views function goes here. You can read the name, symbol, decimal, total supply, and of course check your balance. You can do all that in Voyager, and you can also write. Sorry, I don't have that, but write is over here. This is where you transfer, approve, and all your ERC20 functions that you know and love. So, Cairo 1 thoughts. So I've made this shortcut or cheat sheet. I do have some thoughts that I want to include. Definitely an improved developer experience over Cairo 0, especially when they have loops. It's slightly hard to figure out syntax sometimes. So the strategy is to revisit the examples in the Cairo repo. So once you have seen some examples, you just have to like mentally translate them in your head, remember the syntax, and then you're able to write code, just like you would in Solidity. And at that point of time, at this point of time, like the Cairo version updates from time to time. Sometimes it's kind of annoying, like like you need to have the CLI on Python, and you need to deploy. You need to like compile in Rust, but Scarp is a tool that helps you do that all in one package. So Scarp is the workaround for that. And we're verifying code, like it's still WIP, at least on Voyager, because it's just not easy to do that logic, but we are working on that. So that is not ready, but it's work in progress. So how do you reach us? Now that you know more about Voyager, like if you want to ask questions, how do you reach us? So we have a Discord channel. This is our link, and this is our QR code. And we do have like a Starknet corner. Over here, we have a couple of sub-channels. Voyager is one of them. So this is a place for you to ask questions, give feedbacks. And if any one of you want to translate Voyager to your local language, just like Gilwook did to Korea, I highly encourage you to let us know, and we'll get you started on how to translate our website to Vietnamese, for example, or any other language. Thanks, Gilwook. Shout out to Gilwook and the lots of people. And we do have a Twitter page of Nethermind, twitter.com/nethermind.eth. And this is where we share all our developments on Nethermind, not only Starknet. So yeah, thank you so much. And I hope you enjoy the session. I hope you start writing your first Cairo code the moment you get back. And if you have any questions, I will be at the booth, and I hope you enjoy today's session. Thank you so much.